Dear second prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce new mathematics lesson. The lesson today, inshallah, will be Algebra. It's Unit 1, Lesson 6. The lesson is called Intervals. But we are going to divide this lesson into two parts, okay, because we have many many problems on this lesson. In this lesson, inshallah, in this part, we are going to learn what the meaning of the interval, and we are going to learn what's the difference between the interval and the set, and we are going to learn how to represent this interval on the number line. Let's start the lesson. First, before introducing what the meaning of the interval, we need to remember a concept called inequality. Okay, we studied in the last year this form. This form is called set. If we have A equal set, A here is the name of the set. Okay, X such that X, this is represent the elements or the numbers inside the set called X. Okay, X here belongs to N, and N is the set of natural numbers. That means X is a natural number, or X is a number from N. Okay, X here, and this is the condition of the inequality, greater than or equal to and smaller than or equal 4. Or equal, that means the number 2 is included, okay, and smaller than or equal 4, that means the number 4 is included. Now we have X greater than 2 and or equal to, smaller than or equal 4, that means X here equal 2, 3 and 4. Okay, 2, 3 and 4. Now I wrote the name of the set A equal set 2, 3 and 4. Now I need to represent this set on the number line. Okay, we draw the number line like that, like this, and then write the numbers, and each of them plot with a point like this, or shaded circle like this, 2, 3 and 4. Now we have a space between 2 and 3. This space included the decimal numbers, but we haven't decimal numbers inside N. Then we leave this space empty without any shade. Okay, and here also empty space between 3 and 4 because we haven't natural numbers between 3 and 4. Let's take another example. If we have another set called B, this set included elements called X. X here belongs to N also, and X greater than or equal to, that means 2 is included, and smaller than 4, that means 4 is not included. Now we have 2 and 3 only because 4 is not included inside the set B. And if we want to represent this set on the number line, we are going to write 2 and put shaded circle above it, and 3 and shaded circle above 3, but 4 here doesn't include any number. Okay, now we studied the sets inside N. Let's study this sets inside R. R, the set of real numbers. If we have set C here, included X such that X, and X is the numbers inside the set as we said before. Okay, and X belongs to R. R here all the real numbers, and R represent the whole numbers and the decimals and the fractions and the roots beside pi. That means if we need to represent all the real numbers from 2 to 4, okay, now I need to represent all the numbers between 2 and 4. It's impossible to write this number by listing method inside a set. Then I'm going to represent this set inside on the number line like this. Plot 2 and shaded circle above, and 4 and shaded circle above here. Okay, and then I'm going to connect between them because all these numbers are real numbers. Then I have to shade the space between 2 and 4, but here I can't shade this because this is a natural numbers which has no decimal points. Now I need to represent this form in form of set. Okay, now I can't, as I said before, I can't represent this form in form of set or by listing method, because it's impossible to write all the real numbers between 2 and 4. Now I need a new form to represent this one. This form is called interval. Then the interval is what? The interval is the representation of the real numbers, okay? Because I can't write the numbers by listing method, then I will represent them by the new form which is called interval. The interval written in this form, C equal bracket 2 comma 4 bracket. Okay, 2 and 4 are the limits of the interval. The limits here are 2 and 4, or 2 and 4 as we explained in the set. But the form of the bracket or the direction or the bracket, okay, has a meaning. If the bracket face inside the or directed inside the interval like this, it will represent shaded circle, or that means the 2 here is exist. Exist means inside the set, the interval. Okay, and 4 here also, the bracket face to 4 or its direction inside the interval, that means 4 here is a shaded circle and it exists. Okay, now I can say that this interval included 3 kinds of numbers. It included 2, which is the start, 4, which is the end, and all the numbers between them. Now let's study another example. If we have a new set called D, included x such that x, and x is the numbers inside this set D, and this is belongs to R. X here greater than 2 but not equal, and smaller than or equal 4. That means x here all means all the numbers between 2 and 4 and 4, but we haven't 2 because there isn't any equal sign here beside x. Okay, x were represented, D were represented like this. 2 were represented by open circle like this because 2 is not exist, and 4 were represented by shaded circle. Here I need not to write 3 like the previous example. Okay, I need only to write the start and the end of the limit of the interval, and I will shade, of course, between them. Now I have what? I have in this interval, I have 4 and the numbers between 2 and 4, but I haven't 2. It will represented as in the form of interval like this. 2 and 4 are the start and the end, or the limits of the interval, and here the bracket face outside the interval because 2 is not exist and 2 is open circle. Then 2, the direction of the bracket will be to outside the interval, but 4 is exist. Okay, then the bracket will face to 4 or to inside the interval. Okay, let's take another example. If we have a new set called E, such that E included x such that x belongs to R, and x greater than 2 and not equal, smaller than 4 and not equal. That means x here all the numbers between 2 and 4 without 2 or 4. Okay, to represent this one on the number line, I will write the number, draw the number line like this, and write 2 with open circle and 4 with open circle because I haven't 2 or 4 because there isn't any equal signs, and of course I will shade between them because I have the numbers between them. It will be in the form of interval like this. 2 and 4 are the limits of the interval, and the brackets face to outside because 2 is not exist, 4 is not exist. Here we have 3 kinds of intervals. The first one closed from both sides, which is called closed interval, and the second one closed from side and opened from another side, which is called semi-closed or semi-opened interval. In the last one, we have two opened circles. It called opened intervals. Now let's study the kinds of interval, but now I defined the meaning of interval here. Okay, if we have closed, that mean from both sides, that mean 2 and 4 are exist plus the numbers between them. Here 2 is not exist, 4 exist plus the numbers between them. Here 2 and 4 are not exist, but the numbers between them are exist. Okay, let's study the types of intervals. The types of intervals, we have two types of intervals. The first one called limited interval. Limited interval, okay, that means interval that has a start and end, okay, as all the previous intervals I studied in the last examples. Okay, for example, this interval x greater than 2 and smaller than or equal 4, we have here limit, it's 2, and we have here limit, it's 4. Okay, it doesn't related the equal or the equal sign or not. Okay, we have to define the interval is limited. Okay, we must have start and end, and this is represented on the number line like this: 2 opened, 4 closed. Because we have start and end, then this one called limited interval and represented as we learned before like this. Okay, the other kind, which is called unlimited interval. Unlimited interval is interval which has a start and hasn't end, okay, direction. For example, if we have set B such that included x such that x belongs to R and x here is greater than or equal 4, that means x start from 4, okay, with no end. 4, 5, 6, 7, 8, 9, 10 and so on with no end. When we represent this one, okay, first I will write 4 with a shaded circle like this because we have equal sign, and here x greater than 4, then we have all the numbers in this direction, okay, like this. But here I will draw an arrow like this because we haven't a limit or end to this interval, okay, but I have to write a limit. In that case, we are going to write this limit like this, which is called unlimited or infinity. This one is called infinity, means, okay, the numbers go with no end. To represent this one in the form of interval, we are going to write 4, okay, closed, and infinity here. And the infinity here means number non-exist. This number is greater than any real number. Okay, here infinity, because infinity is not exist, then infinity is always opened. Okay, then this one is called unlimited interval. Start at 4 and hasn't no limit or hasn't no end. Okay, it goes to infinity. Another example to unlimited set: C included x such that x belongs to R and x smaller than or equal to. The start here is 2 and x all the numbers smaller than or equal to. Okay, let's represent on the number line like this. This is the number line. I will write 2 closed like this, and the numbers smaller than 2 will be to the left. To what? To infinity. Okay, like this. Here in this direction the arrow goes to infinity. In this direction we have here 2, 1, 0, negative 1, negative 2 and so on. This direction represents the negative numbers. Then we have here negative infinity. Okay, the interval written like this: negative infinity from the left direction it will be opened, and 2 from the right direction, and it will be closed because we have equal sign here. Okay, negative infinity, exactly as positive infinity, it's always open. Okay, now we studied the types of intervals. Let's study special cases of the intervals. Okay, the first special interval with us called R. R is a, we can represent it with interval like this. Okay, if we have a number line like this, included infinity to the right, negative infinity to the left, and 0 at the middle. Okay, R here represent all the numbers on the number line, or the whole number line like this. Okay, R here, its start is negative infinity and its end is positive infinity. Then R written in the interval form like this, from negative infinity to infinity. The second example, we have R positive. R positive, all the set of positive real numbers. Okay, R positive represent the numbers here in these directions from 0 to infinity, but 0 is not a positive number. Then we are going to represent 0 by open circle and the direction to infinity like this. It will be represented as 0 opened and infinity opened. Okay, finally we have R negative, which represent the negative numbers which are in this direction like this. 0 is not a negative number, then 0 also here will be opened and the numbers will be in this direction. R negative represented as negative infinity and 0. You have to study the three elements, the three sets, okay, in form of interval, because we are going to use these forms in the next, inshallah. Let's solve examples about this part. In this example, complete the following table. Okay, now this form is called characterized method or description method. I need to change this form into form of interval. Okay, the first I'm going to read the interval, the set. X here is greater than or equal negative 1, smaller than or equal 2, and X here belongs to R, as we see here, or this represent a real number. Okay, first, because we have equal sign here, then we are going to make this a closed interval from both direction like this. Okay, and I'm going to write negative 1 to the left and 2 to the right. The next one, X is greater than 0. Okay, we have an equal sign here. Then I have here open bracket like this, and I will write 0. X smaller than or equal 3, then 3 is closed like this. The next one, I have here X smaller than 4, but I haven't equal sign here. Okay, if I need to represent this one on the number line like this, I will have 4 in the middle, and 4 here is opened. Okay, X is smaller, it will be to this direction. This direction goes to the negative infinity, as I explained. Then this one represented by negative infinity and 4. Negative infinity here is opened, and 4 here is opened because we haven't equal sign here. Okay, the next one, as I explained in the special cases, R can represented by many different ways. R equal Q union Q dash, or R equal R positive union R negative union set of 0, or R can represented by this one from negative infinity to infinity. The next one, R positive. R positive is the positive numbers with the start after 0 or 0 opened, and infinity, it will be here, it's 0 opened and infinity opened. Okay, the next one, R negative. R negative is the numbers less than 0. Okay, the numbers less than 0, it's from 0 opened to negative infinity, or from negative infinity to 0 opened. Now I have non-negative. Non-negative numbers. All the numbers are three kinds: negative, 0, and positive. Okay, when we say non-negative, okay, then we mean 0 and the positive numbers. The positive numbers are 0 and infinity opened. Then if we add 0 to this one, it will be closed and infinity opened. Here, non-positive real numbers. Also, if we have negative, 0 and positive, okay, if I need the non-positive real numbers, okay, then I need negative and 0. Then it will be from negative infinity to 0 closed. It will be here. The next example, and this one, complete using belong or doesn't belong. Okay, here in this interval, we have three kinds of numbers. We have 3, we have 5, and the numbers between them. Then 3 is included, then 3 is belongs to this interval. Number 2, negative 2. Here we have from negative 2 opened to 1 closed. Negative 2 here is opened, that means negative 2 is not exist. Then negative 2 doesn't belongs to this interval. Finally, we have root 9, which is equal 3. In this one, we have from negative 3 to infinity. It will be like this. Negative 3 opened, okay, till infinity, like this. Okay, 3 exists in this position. Then 3 included inside this interval, it will be belongs to this interval. Here we have cubic root negative 1, which is negative 1. Okay, in this one we have from negative infinity, okay, to 1 opened. It's clear that negative 1 is included inside this interval. Then negative 1 belongs to this interval. And this is the end of the lesson. I hope it was helpful for you. See you in the next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.